All right, let's dive in. Today, we're going to unpack the top 10 essential ideas that really power the world of machine learning. You know, that incredible technology that's kind of quietly reshaping our entire world, one decision at a time.
I mean, have you ever stopped to wonder how that actually works? How your phone knows it's you, or your email just knows what's junk? It can feel like absolute magic, but it's not. The secret lies in this fascinating field of machine learning. And in this explainer, we're going to pull back the curtain and see exactly how the trick is done.
So, here's our game plan. We'll break it all down into 5 simple parts. First, we'll cover the big one. What even is machine learning? Then, we'll explore the 3 main ways machines actually learn. After that, we're going to peek inside the AI brain, see how they perceive our world, and finally, we'll wrap up by looking at what's coming next and the huge responsibilities that come with all this power.
Okay, first things first, let's tackle that big question. What on earth is machine learning? At its very core, it's a completely different way of telling computers what to do.
Here's a really simple way to think about it. Traditional programming is like giving a computer a super detailed, step-by-step recipe. Machine learning, on the other hand, is like showing it thousands of pictures of cookies and just letting it figure out the recipe all on its own by spotting the patterns. It's learning from experience, not just following a rigid set of instructions.
All right, so now that we have a sense of what this stuff is, let's get into the how. How do machines actually learn? Well, it turns out there are 3 main styles they can use.
The first 2 are actually pretty easy to grasp. With supervised learning, the data is all labeled. It's just like studying with flashcards. We show the AI an email and say, "This is spam," then another, "This is not spam," and it learns from all those examples. Then you have unsupervised learning, where there are no labels at all. It's like dumping a giant pile of Legos on the floor and telling the AI to sort them out. It has to discover the hidden patterns and structures all on its own.
And the third style, reinforcement learning, is all about trial and error. Imagine an AI learning to play a video game. It tries an action, like pushing a button. It gets feedback, either a reward, like getting points, or a penalty, like losing a life. And over millions and millions of tries, it updates its strategy to get the most rewards possible. It literally learns by doing.
So we know how they learn, but what's actually doing the learning? Let's pop the hood and take a look inside the architecture of the AI brain.
You know, everything starts with the artificial neuron. It's the simplest, most basic building block. Think of it as a tiny decision maker. It takes in some information, does a quick calculation, and then passes a signal along. One on its own is pretty simple, but they become incredibly powerful when you get a whole lot of them together.
So when you connect millions of these simple neurons together in layers, you get what's called a neural network. Information flows into an input layer, it gets processed through all these different hidden layers of specialists, and then an answer pops out of the output layer. This fundamental structure, this is the foundation of pretty much all sophisticated AI today. It's what lets it do things like recognize a face or understand a sentence. And you've probably heard the term deep learning, right? It sounds really complicated, but the idea is actually pretty simple. A deep learning model is just a neural network with many, many hidden layers. That depth is what gives it the power to find much more complex and subtle patterns in data, and that's why it's behind so many of today's biggest AI breakthroughs.
So now we have these powerful digital brains. Let's look at how they're applied to create abilities that we recognize from our own lives. Things like seeing and speaking. Natural language processing, or NLP, is all about teaching computers to understand our language. Seriously. Every time you talk to a smart assistant, or use a translation app, or get a reply from a chatbot, yep, you are seeing NLP in action.
And remember our first question about how your phone knows your face? Well, this is the answer. Computer vision. It gives machines the ability to see. It's what lets your phone unlock, what lets a self-driving car identify a stop sign, and what lets software help a doctor analyze a medical scan. It's all about teaching a machine to interpret a bunch of pixels as meaningful objects.
We've covered the core concepts, but this field is moving so incredibly fast. So for our final section, let's look right at the cutting edge and the profound responsibilities that come along with it.
The biggest breakthrough happening right now is generative AI. For years, AI was mostly about analyzing information that was already there. But now it can create totally new, original content. It can write an essay, compose a song, or generate a stunning image from just a few words of text. This is a truly monumental leap forward.
But, of course, with great power comes great responsibility. This warning from the physicist Stephen Hawking is a really sobering reminder of just how high the stakes are. As we build these incredibly powerful tools, we have to be extremely thoughtful about how we do it.
And this brings us to a huge point. AI learns from data created by humans. And because of that, it can inherit and even amplify our own biases. So if we train a system on biased data, it's going to produce biased results. It's that simple. And that's why building responsible AI, focusing on things like fairness, transparency, and accountability, is just as important as building powerful AI.
And that really leaves us with the ultimate question, doesn't it? As machines get smarter and smarter, how do we make sure they also get wise? It's not just about building intelligence anymore, it's about cultivating wisdom. Definitely something to think about.